Okay, so here's our first example. Softball players. Here we go. The pitcher's mound on the women's softball field is 43 feet from home plate. I hope that's actually true. Is that true? Okay. 43 feet from home plate, and the distance between the bases is 60 feet. FYI, the pitcher's mound is not exactly halfway between home plate and second base. How far is the pitcher's mound from first base? Okay, so let's set up our picture here. We've got our softball. I don't know where that's green. It's supposed to be black. We've got our softball diamond here. Okay, the pitcher's mound is 43 feet from home plate. That's supposed to be a straight line right there, but that's 43 feet, not degrees. All right, the distance between the bases is 60 feet. So we've got 60 right here. We really don't need to label all the other ones because it's not important to our problem. The question is, how far is it from the pitcher's mound to first base? Now, I know that looks like a right angle, but it is not a right angle, okay? But what is a right angle? This is a diamond, softball diamond, baseball diamond. So all of these angles on the outside of, in the square, so to speak, okay, are 90 degrees. So this angle down here is what? 45. Okay, so this is a simple law of cosines problem that we need to set up. We're trying to find the distance, so x squared equals 43 squared plus 60 squared. Yes, sir? No, that's where it comes into play that the pitcher's mound is not halfway between home plate and second base. Stop. Just turn around. I'm talking to anybody that's not focused on the problem right now. Okay, now, is that the distance from the pitcher's mound? No. What do we have to do? Take the square root. And let me make sure, yeah, still in degree mode. Okay, so the distance is actually approximately 42.43 feet. So, interesting to know, right? All right, let's look at another. Let's go back to another ship. Okay, a ship travels 60 miles due east and then adjusts its course and begins traveling in a northeast direction. Okay, so let's write down what we've got so far. So we start here. I'm going to put an S for start. Okay, we go 60 miles due east, and then it begins traveling in a northeast direction. It doesn't tell us what that direction is. We're just going northeast. Okay, that would be northeast. After traveling 80 miles in this new direction, so we've got 80 miles right here, the ship is 139 miles from its departure point. Okay, so that distance is now 139 miles. Describe the bearing from point B to point C. Okay, so we are trying to find what angle did it turn through to get from B to C once it stopped traveling due east. So it would be helpful if we start with that angle right there in the middle, right? We need law of cosines. And we are solving for angle B, so that means side B needs to be over here by itself. 139 squared is equal to 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine of the angle at B. Okay, remember this is the one we need to be a little bit more careful with. As we solve, we need to chunk it down, but even be careful with that. Okay, 139 squared minus 60 squared minus 80 squared. Okay, we get 9,321 over here. 2 times 60 times 80 is what? 900, yeah. Negative 9,600. We divide 9,321 divided by negative 9,600. Yes, the negative matters big time. The inverse cosine of the answer gives us 166.15 degrees is the angle at B, but that wasn't what they were asking us for. They were asking us for describe the bearing from point B to point C. So what we've got going on here is we've got 90 degrees. The bearing is actually when we take away 90 from that 166. Okay, because we got to start with the north and figure out how many degrees east we went. So that would be north 76.15 degrees east. Okay, because we've got to describe from this north-south line right here, how much did they turn? Okay. Or we could have also talked about the fact that we were going due east and turned towards north to get there. How would we figure out that part? Subtract 166 from 180. Okay, 180 minus 166.15. So we could also describe this as east 13.85 degrees north. Okay, those are describing the same movement. It's just, where did we start from? What's our reference point? Are we talking about going north and turning east? Technically, we're talking about the fact that we were going east and turning north. So really, that would be the east 13.85 degrees north would be the better answer, because that would be the answer that the boat captain needs to know to get to point C. Make sense? Ish. Enough?